Here we are going to talk about one more important term, that is water balance equation with respect to hydrology. So this water balance equation is a key concept in hydrology and water resources management. It finds its importance in its ability to account for all the water which is entering, leaving and getting stored within a system. Now when we refer to a system, this system could be anything, that is it could be a soil column. Okay, so what is the amount of water which is entering into a soil, what is the amount of water which is leaving from the soil, and what is the amount of water which is getting stored in the pores of the soil. So here also we can apply a water balance equation, and it could be also a entire watershed or drainage basin. Okay, so basically it is a system which represents the total amount of water which is entering into a system, leaving from that system and getting stored into that system. And mathematically this equation could be represented as input is equals to output plus change in storage, that is I is equals to O plus delta S. Now when we see this equation from an hydrology point of view, then input parameters could be, I could be precipitation, then surface inflow, subsurface inflow, etc. Okay, then if we talk about output, then it would be evaporation, transpiration, evapotranspiration, subsurface outflow, surface outflow. So this could be the outflows from a system, and change in storage could be the detention storage, depression storage, channel storage, the water which is stored within the irrigation canals, then change in soil moisture storage, etc. Okay, so these are the input parameters, these are the output parameters, and these are the change in storage parameters for a water balance equation in case of hydrological cycle or from an hydrology point of view. Okay, so I can rewrite this equation also as P is equals to O. Okay, in case of output I forgot runoff, so runoff is also an important parameters. So runoff we can represent it is at Q, then evaporation, then transpiration, and for the change in storage we can represent it as delta S. So mathematically we can represent this equation as follows, and this equation find its importance in planning irrigation and drainage systems, in managing watersheds and river basins, in flood controls, pollution control, etc. Groundwater management and recharge related studies could also be carried out using water balance equation. So simply it represents input is equals to output plus change in storage, or here I can write it as input minus output is equals to change in storage. Thank you.